let's review list mutation and environment diagrams. Names can refer to lists, and assignment statements can change which names refer to which lists. In addition, the contents of a list can change, the length of a list can grow or shrink, even if the names that refer to those lists don't change. And environment diagrams help keep track of all this change as it's happening throughout the course of execution of a program. So let's work with an example where S is bound to the list 2, 3, T is bound to the list 5, 6, and we perform various mutation operations, have some example calls, and show the result. And we'll start with the append operation, which adds one element to the end of a list. So if I append T to the list S, here's what happens. I start out with a global frame with S bound to the list 2, 3, and T bound to the list 5, 6. S.append T adds one element to the end of S that refers to this list containing 5 and 6. It's important that this arrow doesn't point to the name T. It has to contain a value. It's the value that you get when you evaluate the name T, which is the list containing 5 and 6. Now when I assign the name T to something else, like 0, that means T is bound to 0. It's no longer bound to the list 5, 6, but that does not affect S. S is now 2, 3, and a list 5, 6. That's a 3-element list containing 2 numbers in a list, and T is bound to 0. Okay, let's start over and take a look at extend. Extend adds all elements in one list to another list. So S.extend T will add to the end of S the elements 5 and 6. Now if I assign T1 equal to 0, I will change this element to 0, but that won't affect what's in S because S just contains a bunch of numbers. Let's start over once more and take a look at addition and slicing. Addition of 2 lists creates a new list, and slicing creates a new list. These lists contain the elements of the lists that were added or sliced. And here we'll do a longer example. We're going to assign A to S plus a list containing T. We're going to assign B to a slice of A, and then we'll make some changes to A and B and see what happens to S and T. Starting at the top, if I added S and T together, I'd get a list 2, 3, 5, 6. But this is different. This says build a 1-element list containing T. So let's go ahead and do that, even though we're not going to give it a name. Instead, we're going to add this list and this list, building a new list containing the elements 2, 3, and the list 5, 6. So the result of this expression, S plus list T, builds a 3-element list with 2, 3, and a list, and we give this the name A. Now before we move on, we should probably figure out what to do with this floating 1-element list that has no name. You could leave it there. You could also erase it because it can't be reached. It was created during evaluation but never given a name. Okay, on to the second line. B is a slice of A, starting at element 1 and going to the end. That creates a new list containing 3 and the list 5, 6. Now we can make some changes. A's element 1 is 9. Here's A, here's element 1, that changes to 9. B's element 1's element 1 is 0. Here's B, here's B's element 1, here's B's element 1's element 1, and we change that to 0. That actually affects T. So the result now is that S is a list 2, 3, T is a list 5, 0, A is a list 2, 9 containing 5, 0, and B is a list 3 containing 5, 0. The fact that this addition and this slice all contained T means that a change to T affects all 3 of them, and therefore we see 3 different zeros all referring to the same element of a list. Okay, let's start over. The list function creates a new list containing existing elements. So if I say t equals list s, I get a new list containing 2 and 3. That replaces what t used to refer to. If I set s element 1 equal to 0, then I'm changing s, but I'm not changing t because we copied it. So the result is that s is 2 and 0, and t is 2 and 3. What about slice assignment? Here is an example. If s is 2 and 3, t is 5 and 6, and I assign to the list s from 0 to 0 equals t, I'm saying that right in here I should have all the elements of t. Since this slice had length 0 and this list had length 2, I had to shift everything else over. Slice assignment from 3 onwards means that this value is going to change, but since I'm replacing a slice of length 1 with a list of length 2, I put the elements 5 and 6 in place. Now t1 equals 0 changes this value, but it does not change this value because the last element of s is just a number. So those are ways of extending or changing a list. It's also possible to shrink a list. I'm not going to draw environment diagrams for these because I think they're pretty straightforward, but let's go through the operations. Pop removes and returns the last element. So if I start with s is 2, 3 and t is 5, 6, and then assign t to s.pop, that removes the 3 and changes t to refer to that 3. So the result is that s is a list containing only 2 because I popped off the 3, and the 3 is now the value of the name t. We've lost track of the list 5, 6. Starting over with s is 2, 3 and t is 5, 6, what if I remove? Well, remove removes the first element equal to the argument. So if I write t.extend t, that means t is now 5, 6, 5, 6. And if I remove 5, then I'm left with just 6, 5, 6. S has not changed at all.